compare across all of the criteria that we specified up front. This is really powerful because this is the kind of work that you would expect an analyst to spend a large amount of time doing. And deep research is able to complete this for you and save those analysts time, and also do it much faster so that you can make faster strategic decisions and consider more options. One of the powerful features of deep research is that all of these web searches that it's doing, it provides transparency to you about how it's using that information to produce the final answer. So you're able to find citations for each of the pieces of information that deep research pulled together. And you can go and verify its work or go deeper on any of the questions where you might want a little bit more detail than deep research provided. So one of the other kind of like powerful features of deep research is that you can actually view its reasoning process as well. And you can click in and understand how it came to the final answer, which I'll show you in a second. So this is a business strategy use case, and this indicates one of the powerful capabilities of deep research, which is broad kind of questions that require synthesizing a large amount of information in an ambiguous setting to provide an answer to a business question. But deep research also excels at finding answers that are difficult to find about very detailed questions. So this is an example in M&A. So suppose that we are looking into land power deals for maybe a large data center that we might want to build, for example. And we have a hyper-specific question here that requires a lot of industry knowledge to answer in an accurate way. Deep research excels at these types of queries as well because it's able to find rare and difficult to find sources of information on the web and pull those into its final answer. And so you can see the report here provides detailed analysis across a number of criteria, and even breaking this down over different regions and other ways of splitting this query into subcomponents that might be valuable for us. So this is an M&A example, but let me show you one that is a little bit more relevant to our team at OpenAI today. So we announced deep research today, and one thing our marketing team might want to do is to understand, what are people saying about this? How are people reacting to this launch? Is the media positive on it? Are people on social media excited about it? And deep research excels at these types of use cases too, because it's able to access all of these sources of information and instead of pulling together all of them, synthesize key points across them. This is the kind of task that marketing teams can do, but oftentimes when we're busy with the launch, we don't actually have the bandwidth for our marketing team to do this kind of detailed analysis for every single thing that we would like them to. So deep research enables marketing teams to scale their efforts and serve a much wider set of use cases. Hopefully this gives you an indication of the types of use cases, the breadth of the use cases that we think make this technology so exciting for enterprise. But deep research is useful beyond enterprise as well. So it's also useful in our personal lives. If you have a question that you want to ask about a hobby of yours or sports, or you're doing some shopping, and it's a similar type of question where you have a kind of a very detailed set of criteria that you're looking for an answer to, deep research can pull together answers for these things too, such as summarizing baseball statistics and making comparisons across a large number of baseball players. Beyond just enterprise and consumer use cases, one of the things we're really excited about deep research enabling is accelerating scientific research. So here's an example that we put together in a domain that's very familiar to me, that's kind of closely related to my PhD research in deep learning and robotics. And the report that it pulls together, a lot of experts describe these reports as being kind of at the level of an advanced undergraduate or an early graduate student level work, because it pulls together many sources and summarizes them in a way that requires sort of sophisticated understanding of the nuances and the details between these different use cases. So this is an indication of the breadth of the types of things you can use deep research for. Now let's come back and check on the go-to-market strategy question, the sales question that we asked in the beginning. But before we look at the final answer, just to show you kind of how much of a leap forward in capability this is, I'm going to try asking the same question to regular ChatGPT without using deep research. So conduct a detailed analysis. Actually, I will just jump in here and I'll copy the exact one so we can get a a fair comparison. You can already see how detailed this report is. So we'll type in the same query. And the advantage of using a chat model over using deep research is that you get an answer much faster. So here we're going to get some, here's kind of our ChatGPT model giving a high-level analysis of this strategic question. This is kind of the type of answer that you might expect someone who is thoughtful and has read a lot about SoftBank to answer kind of off the top of their head in a first pass. So if you want an answer fast, using chat models is a great way to do that. But if you want a detailed answer, then deep research provides a much better solution. And so you can see, even just by the length of this, how much more research and work has gone into producing this answer. And the level of detail and insight that this goes into is far beyond what you can get out of the box from ChatGPT, including industry focuses, financing of these deals, business strategies. Each one of these claims, each one of these insights, backed up by supporting evidence, just like an analyst that you hire at your own company would do. So this is an overview of how you can use deep research in enterprise use cases. And as you can imagine, this is only the beginning for these types of agentic technologies transforming enterprise. Giving models access to web search unlocks many use cases, but not all use cases. In enterprise, oftentimes the most valuable data is the data that you have in your company. So you can imagine us starting to expand this to accessing other types of information, like internal information. And you can imagine these agents going beyond just synthesizing knowledge, starting to create knowledge or take actions in the world as well. So that's the roadmap of where we're hoping to go with this technology. And so from there, I'll hand it over to Michael to talk a little bit more about how enterprises can start to customize these applications and how we think about that ourselves. Thank you.
Hi, thank you. I'm honored to be here and show this to you. So 2025 is the year of agents. But what does that mean? We're all sitting in this room right now, not pulling out our phones and typing into deep research or ChatGPT. So I wanted to show you a different take on what the future of your organizations could look like. This is a small demonstration just to hopefully inspire you and give you something you can bring back as you look ahead to the rest of this year. Let's start with something we know, sales. Here we have a sales contact form where someone is trying to reach out to OpenAI to learn about ChatGPT Enterprise. Now, we know how this usually works. Someone submits this form, it goes into a system, and then a team of people, account associates, are reviewing the leads to reach out and figure out how best to respond. And this can take hours or days and feel like a slow process for your buyers. What could it look like if you had agents inside of your workforce working for you right now? So first, we'll submit the lead here. And we'll come over to our system. Here you can see what a virtual teammate, a virtual sales associate, could be doing for you with our technology. If we open the task here, we'll see that the agent is picking up work for you already to try to help this lead. The account email came in, and already it's doing what a sales associate might do on their own and researching that lead, figuring out the industry, the revenue, title, and other information. Think back to deep research that you just saw and imagine the ways that this could plug into this as well. It's really exciting. Now, in this case, the agent was able to see that this is a really good prospect. OpenAI wants to buy OpenAI, so we think they're a good customer. And so we're going to get the calendar availability and figure out when we might hop on the phone with them. Then it's going to write an email and get back to them. Now, in this case, this agent hasn't been told to write in any specific language. It's really smart. It realizes that the prospect wrote in Japanese, so it's going to write back in Japanese as well. And sure enough, if we come over to our inbox, we can see that email right here waiting for you. Again, this is just a small demonstration that we wanted to pull together to help you see what it could look like. You can imagine the applications for this are endless. If you start to look around your organization, think about all the small tasks that people on your teams do and the ways those add up. This doesn't have to be an all or nothing process. You can really chip away at this and bring the latest technology into your workforce now and help save your team time and focus on the next steps after that. I hope this is inspiring, and I can't wait to hear what you do with this, deep research, and everything else. Thank you.
アーム CEO レネ・ハースでございます。
Konnichiwa. Very nice to be here today and speak with you about ARM and how we fit into everything going on with agents and the things that Masa and Sam just talked about. Now, I think you may know ARM well, but just to remind everyone about our company, we are a compute platform with unmatched scale. Since we were started in 1990, over 300 billion chips have been shipped with ARM inside. No compute platform even comes close. And now as we move into the age of artificial intelligence and all the connected devices, 99% of the connected global population runs AI on some form in some way on ARM. And we have a developer community unlike anything that has ever been created for the compute platforms. Over 20 million developers. So the last 35 years of ARM have just been incredible in terms of our growth, our breadth, market penetration. But we think the future is just beginning. And agents and AI running on ARM is the future. I'd like to show you a short video about how we see the future and the vision about agents and ARM.
AI agents are changing how we live every day. They help us shop, book, drive, stay healthy, and even build the technology of tomorrow. And at the heart of it all, ARM's compute platform. Shopping is easier than ever. AI agents running on ARM know what you need, find the best deals, and even let you walk out without stopping at a register. Reservations, adjustments, and even remembering your favorite lunch spot, handled instantly. All so you can focus on enjoying the moment. Making driving smoother and safer, helping you navigate, park, and even take the wheel when you need it. And it's all running on ARM. Early detection, real-time monitoring, and life-saving support for doctors. Smarter technology leads to better health outcomes. AI agents don't just run technology, they help build it. ARM-powered AI is transforming how developers code, test, and create. From how we shop to how we move, eat, stay healthy, and create. AI agents are changing our lives. The future of AI is built on ARM.
So one of the very important things when we think about agents and the compute platform is that these agents running everywhere will require more and more power-efficient compute because the devices that we have today still need to run displays. They still need to run operating systems. They still need to run applications. But yet on top of that, the agents are going to be making our lives much easier, but will require the most power-efficient compute, and that's where ARM fits in. Now, we are the compute leader from cloud to edge. When you're talking about the largest data centers or the smallest embedded devices such as thermostats or security cameras or earbuds, the world is using ARM in all these areas. Now, one of the unique attributes of ARM is the fact that the software is common across many of these platforms. The operating systems that run on your phone or run on your PC or in your automobile or even in the cloud, That is the key in terms of how these devices go. But in the future, these agents will be running on top of the operating systems. So some of the very interesting demos that we just saw really begins to abstract away some of the things that are going on at the software level. Now, that is magic to the user, but it takes a lot of hard work to really make it all go. And one of the things that ARM brings to this problem is a solution we call the ARM Claddy AI libraries. And this allows the agents to just work. That is, for the developer who's writing the agent to be able to write it in such a way that knowing that whether they're running it on a phone or a PC, the data center, a car, it's just going to run. We envision a world where these agents will be running everywhere, not just on your PC where you can query demands, but agents will be talking to agents and other agents and other agents. And our job at ARM is just to make that very easy for developers and make it very power efficient. So I think the future is so bright for this technology. I just want to bring Sam back up here for a moment and just chat for a second, because I think when we look at the future of agents, Sam, you showed some pretty cool demos there. I can imagine a world where the agents are just not running on a sophisticated device, but probably almost every device you can think of.
Yeah, I think the network of agents will be the next thing we talk about, and it'll run in the cloud, on device, sort of all over the place. But that seems like it's going to be pretty incredible.
Now, I don't want to put you on the spot here, but
go ahead.
Every time we chat, you say, hey, I have this really cool new demo I need to show you. And just looking at this deep research, when do you think we see a world of agents talking to agents across embedded devices?
Technically, it should be capable now if you could run a big enough model on device. So it's a better question for you.
All right, we got to get the hardware ready.
Yeah. But I think it's one of my biggest surprises about AI over the last few years has been how much we're able to do with a small-ish model. Distillation has just been incredible to watch. So I am optimistic that every device in the world is going to be pretty smart.
Yeah, the future could not be more exciting. Thank you.
Thank you.
Thanks all.
続きまして、トークセッションを行います。準備がございますので、そのままお待ちください。お待たせいたしました。ただいまよりトークセッションを始めさせていただきます。それではお願いいたします。
どうもありがとうございました。今からサムとちょっとフリーディスカッションをしますので、いっぱい知りたいことがあると思いますけど、質問の時間というより僕が代わりに皆さんに代わって、たくさん聞きたいであろうことを今直接サムに聞きますので、楽しみにしていただきたいと思います。サム。 Great demo.
Thank you.
Great demo.
I'm glad you enjoyed it.
Yeah, great. Yeah, so I'm very, very excited that we were able to announce today.
Yes, me too.
Yeah. So how did you feel about the Stargate announcement?
That was quite a moment. It really kind of came, it was so cool to be in there, and
Yeah.
people were excited.
We were talking, can we really make that happen?
Yeah.
It really happened.
Well, we've been talking about doing this for so long that to finally get it all done and
Yeah.
get it out into the world, I think is wonderful.
Yeah.
And the world is going to just need so much compute. It's true that we can, as I was saying just a few minutes ago, get small models to do incredible things, but to really push the frontier of intelligence, that's going to require a huge amount of compute, and the most value will get created at that frontier. So we need a ton of compute to make these models. People are clearly going to want a ton of compute to run these models, and to finally be doing this at scale is totally great.
Yeah.
So I felt really good about it.
Yeah. So about a year and a half ago, we were having dinner, and we were talking, Sam, so when is the AGI coming? How big the compute should be? And the answer from you and the team was, more is better, right? More is better. That was a simple answer. And I started thinking, well, if the more is better, we should do a lot.
Now we're doing a lot.
Yeah, that's how we started.
It is.
Yeah. So it was not limited amount of compute. The more is better, because more brain is definitely better, right? Some people say, oh, you can do small, compress, but that's small.
I think people still don't understand how exponential the return is. The cost is exponential too, but I think the return is even more exponential to the smartest model we can make, and that will require the biggest computer.
Yeah, well, this reminds me the beginning of internet.
Yeah.
Okay? When we started our internet in 1995, it was just a PC with just big letters and very, very slow, very expensive. And then when the broadband came, people said, why do we need that much capacity, the bandwidth? And with more bandwidth capacity, people said, well, this is enough. This is not growing anymore. But then the picture came, more high resolution pictures, and then the video started. The capacity requirement went on and on and on. And people initially saying, oh, internet is just a virtual stuff. It's not really useful. It was mostly free service, so there is no business model. All those criticism seems nonsense.
It seems nonsense now.
Now, all the GAFAs.
I think we'll see the same thing with intelligence. People are like, oh, how smart does it need to be? And the answer is very smart.
Yeah.
And people use a lot of it, and they'll be generating tons of video and solving really hard problems, and everything will be really smart in the world. So,
yeah, your model is actually improving quite a bit, right?
yeah.
Like 10 times a year kind of, model? What's your measurement?
Very roughly, it feels to me like this is like a not scientifically accurate. This is just sort of a vibe or spiritual answer. But every year we move one standard deviation of IQ. Also, every year the cost of last year's intelligence falls by about a factor of 10.
Yes. Yeah. So per chip-wise, cost become 1/10, meaning we can have, with the same budget, we can have 10 times more chip, right?
I think this is, yeah, totally. But also the algorithms get more efficient too.
Yeah.
So this compounds itself. The rate at which this is happening, I think, is easy to take for granted. In 2018 and 19, we had GPT-1 and 2, and people looked at them and it didn't feel that serious. GPT-3 came out. I think that was the first time some people noticed. But GPT-3 barely worked. And if you go back and play with it now, it's like using, I went to one of these old computer museums recently, and I got to use a Xerox Alto. I think it was 50 years old. And you could like see kind of how it did some stuff, and there were the inklings of a modern computer in there. But it was 50 years ago, and it now feels like a 50-year-old computer. GPT-3 is only a few years old, and it feels,
ancient.
if you use it now, it feels like this joke. ChatGPT is only about 2 years old. Came out the very end of November of 2022. GPT-4 didn't come out until March of 2023, I think. So if you just look at the progress here, how quickly the model's gotten better, and also how quickly the models have gotten cheaper.
Yes.
It really points, if we can stay on that curve, it really points to an incredible future.
Yeah. To me, it seems like your model is improving like 10 times a year. And the performance, actually, chip itself, with Jensen's effort, the industry effort, is becoming 10x. And then with the Stargate, we are actually increasing the number of chips 10 times like a year. So 10 times 10 times 10 is like a
big number.
1,000x in a year or two. And then the next year, again, we have another 10 times 10 times 10. That's another 1,000. So 1,000 times 1,000 is a million x. So if you do once, twice, 3 times, 1,000 times 1,000 times 1,000 is 1 billion x, right? So people may say, well, with the recent announcement of DeepSeek, they can sort of mimic and try to catch up. A year later it comes out, it's so much cheaper, but you are still going ahead dramatically more with this 03, 04, maybe sometime soon. So people don't realize the level of exponential, right?
It is hard to really feel the exponential when you're living on it, because you can adapt so quickly, but we clearly are on a very steep one.
It's amazing, amazing. So like a billion X is coming in just a few iterations. But think about next 10 years. It's going to be amazing super intelligence, right? That people cannot imagine
I think so.
today.
Yeah.
Because people tend to think linearly. When exponential comes, it goes beyond people's imagination.
I think so.
Yeah? You are front runner of that.
It is hard to really feel that, but I have learned over my career again and again and again, you just have to trust the exponential.
Yeah,
We're not built to conceptualize it, but you just have to trust.
So you are still excited the level of innovation yet to come. It's not reached
more than ever.
Saturation.
No. We're going to look back in a few years at 03 and be like, man, can you believe how bad that was? Yeah.
Yeah. So people think, bringing agent, prompting, that's too difficult, not for me. But actually, this level of innovation make it easier, right? So user don't have to really do implementation by themselves.
Yeah.
It comes more and more friendly. Like we are talking here with the voice and looking at the eyes each other. We start talking with our artificial intelligence with voice and the eyes.
Totally.
Right?
It's amazing how much value people have gotten just out of a text box, but the world is not just a text box.
Right.
So we will add all of those things.
Yeah. Like talking to this crystal.
There you go.
Right? You just talk and it sees you, it sees your face, and it understands the tone of the voice. And like we are communicating, it will basically communicate with the voice and the emotions and the surrounding, looking at by itself, right? Talking to us.
Yeah.
That's really happening very, very soon.
I think so.
Yeah, well, some people say, Stargate, too much capex, how do you bring the money? Masa, do you have enough money, right? So what do you think? We still need a lot of capacity, a lot of, upside potential to get the technology out of it, right?
Yeah, it's, again, this is the point I was trying to make earlier. I think the returns on linearly increase in intelligence are exponential in terms of value. So pushing each bit we can push the intelligence of these models further, there's so much more value created in the economy. And yes, it takes a lot of capex, but the revenue goes like that too.
Yeah. Well, our mutual friend Elon Musk said,
Your mutual friend.
He says, Master, do you have enough money? I will tell you, we will make it happen. we are not the bank, but we are SoftBank.
I have no doubt.
we will make it happen. So now, the Stargate have to also expand into Japan because of the regulation. We have to respect the national security, the privacy law, blah, blah.
Yeah, SoftBank is building a big data center here.
Yes. So we're going to expand
Well, excited to run on that.
Stargate into Japanese infrastructure also, right? So, well, the innovation, center of innovation is happening, the training, main brain is happening in the state, but there are other peoples in each country, there are other cultures, national securities. So I believe we should expand this, not just Japan, to the other sovereign respect to their culture and their national security, right? So
we certainly do want, we started obviously as an American effort, but our mission has always been AGI for all of humanity. And we really want to find ways that our systems reflect all of humanity and the different values and cultures and languages.
I was amazed, when I took a picture in some part of Japan and say, do you know where it is? And actually, the O1 at that time said, oh, this must be this place. And I said, how did you understand? Did you use a GPS? Well, it says no. I did not use GPS. I look at the stone and the moss on the stone and how the stones are stuck each other. It must be this culture in 500 years ago in this historical location. It has right on.
Pretty good.
I was so amazed. I got blown away. How could the sun know Japan in this? Oh my God. It's so smart. Amazing, huh? So the inference, right? Prediction, inference, not based on all the detailed data, but guessing, make it right on in the historical landmark. It's
fantastic.
Amazing. I got blown away. It even understood my joke. So it was, I actually spoke, said, can you make a joke in Osaka language? In Japan there are dialects. And start making a joke in Osaka dialect, and it says why it is funny. Explain to me. Oh my God.
Fantastic.
It even understand the context, the culture. It's already now, but going forward, I'm using it every day, but I get blown away almost every day still. It's amazing.
Fantastic.
Okay, so we announced the Crystal today. When we do all kinds of source code reading of 2,500 systems, just within our own group, so many source code, billions of coding lines. It must take a lot of, compute.
A lot.
Right?
Yes.
A lot of compute. But you are confident that if we have some, capacity in Japan, the reading all of the source code of 30 years for your model, you are confident that you can do it.
Yeah, we're confident we can do it.
Cool. Look. サムがね、こんなにあっさりと大丈夫だって。
What did you say?
I said, you're so cool. I said, yeah, done. I said, it's amazing, people would expect, oh, right? But you say, yeah, do it. You're so
You did that too.
You're so confident. So I'm very, very happy that we can read all of the source code, but participate real time on the meeting with a long-term memory. We don't have long-term memory yet, but when do you think long-term memory thing can happen?
Definitely within the next couple of years.
Within the next
and maybe even faster than that.
Yeah.
Yeah. Having these models have like, infinite long-term memory, that is so important. An AI that can get to understand your entire life or an entire company, an entire enterprise, that'll be a huge step forward. So we're working hard on that.
My patent, the concept of my patent for long-term memory is that as we are talking right now, okay, I can see a facial expression, emotion, tone of the voice. So all the conversation, I change to text. But understanding tone of the voice and facial expression, I have a emotional map with 250 kind of emotion, and then indexing, and with each of the index like fear or anger or doubtful, right? There are about 250 words for expressing emotions. And each emotion, how angry you are with a 1 to 10 scale. If you are so angry or so doubtful, 10 or 3, I put the index of the strength of that emotion. Analyzing 250 emotion and the strength of the emotion and make it into a numerical index. Text with just 3 numbers of numerical, index attached, then you can compress conversations, and then when you have a very strong emotional vibration, like you're so angry or upset, the multimodal, understanding, like including video, capture the whole thing, captured and stored as a long-term memory. But if you're saying, hey, good morning, good night, like driving on a commute, everyday drive, you're supposed to forget the traffic light or the car passing by. Human brain forget all of those. Otherwise, our capacity of the brain explodes. So you compress all those not important ones, but the one with a surprise or a big emotional strength, that's the one you, without too much compression, you even capture and store the multimodal video and voice and sound, everything, okay? So like, your 3 years old kid birthday, you're supposed to remember that, right? It's a happy moment for the family. So it will automatically capture and store the multimodal data. So that's a long-term memory. And the key is the level of surprise or level of emotion with the index with emotion. So emotion, the human communicate with emotion, not just the text, like I like you, or I like you, or I like you. Completely opposite meaning, right? So the tone of the voice, facial expression, and then if you put the index, that makes the compression and long-term memory. And that context can be very useful for the next conversation, next discussion, negotiation. Like negotiation, you have to read the emotion of the other side, right? Otherwise you fail.
Yep.
So this is the long-term memory with the emotional trigger. That's what I filed 10 years ago. It should be useful very soon, right?
Very soon, yeah. I think, I don't know this, but I think that AI that has emotional expression, so not just like texting in a chatbot, but when you see the motions of like a rendered video avatar or something, that's going to hit us more than we think, and we're going to have to develop some new societal guardrails for it, but it'll also be tremendously exciting.
Yeah, our friend Johnny is supposed to make
He'll figure it out.
such
He's
a
very good.
terminal, right? Yeah. I'm very much excited to see that. So if we have all this, the data and long-term memory and so on, we need lots of capacity, but also latency become very important. Like a call center, customer care call center, we have to have an instantaneous response. Are you confident, let's say in Japan, with this so much enterprise mission critical, are you confident?
You know, I used to worry about that a lot, but even if you use our voice mode today,
Yeah,
it feels like talking to a real person. It's quick.
it's very, very good now.
So I think we'll be able to solve this.
Yeah, only several months ago it was still lots of
Yeah.
data. Today, you know, like even last night I said, wow,
It's very good now.
all three mini, you know, wow, it's so fast. So the latency is now about 100 millisecond or what? Something like that, right?
Something like that. A little bit
Yeah.
more maybe, but it's quick.
Yeah, 100 to 200 milliseconds. Human conversation is about 200 milliseconds, I think. Okay, so 100 millisecond to 200 millisecond is almost human interactive, and you can even still, you know, interact.
You can interrupt. That works well.
That's the key,
Yeah.
right? Because human also interact, and it's really happening. So you are confident. Even the model trained in U.S. and Japan with the Stargate Japan, you know, center, the response of all this real time, you're confident.
Yeah, obviously we'll have to run the model for very low latency things closer to where people are going to use it. But as you said, we can train in the US. We can run a lot of things from the US, especially where it's thinking. And then some use cases we'll have to put out towards the edge.
Yeah. So whatever non-national security kind of thing, you can still do in the US. And national security and privacy things can happen locally in Japan.
Yeah, we can certainly deploy models around the world.
Yeah. So we would allocate 1,000 sales engineers
To the new,
with this new,
Yeah.
you know, joint venture. Those guys have to do the implementation setups to each of the system to establish the agents for each task. So explain a little bit more about how the agent works. Is it a single task agent or a very sophisticated agent or what?
So there will be generic agents that consumers use, and those can do powerful things. Like we just looked at deep research browsing the web. But what you might want for your companies, or I think what everyone will want, is an agent that can act with as much context and information and power as an employee at the company would have. And so you need to connect it to all the systems. You need to give it all a knowledge base. It needs access to the code. It needs to understand how the company works. And that will take a lot of customization work for each company. But think about what can happen once you have it. So someone builds this and integrates it into, you know, let's say into SoftBank. And let's say there's SoftBank and then there's some imaginary competitor that hasn't done this. SoftBank can now do so much more.
Yeah.
And so once you've integrated AI into the workforce, and you have all the power of that, and it's not just the deep research browsing the web or a coding agent writing generic code, but fully integrated into the company, that's going to be very powerful.
Yeah, the company with Crystal, the company without Crystal is like a machine gun and a sword, right?
That's a
No, we shouldn't. That's a maybe wrong example, but the one with the best tool, the one without, is dramatical. It's like a country with electricity with no electricity, right?
Yes.
The country with automotive and bicycle. It's a huge difference in the productivity. That you think will
Yes,
happen
I
again
do.
here, right? Truly.
I think it will be, I think it is one of these moments. You mentioned swords. I collect sort of ancient technological artifacts. And during the Bronze Age, one of the things I have is a sword from the very beginning of that. And they were able to not just forge the blade, but also cast the handle. And so you had swords that had a metal handle that was sort of attached to the blade. And what that meant is you could swing.
Yeah.
Rather than the people that just had a forged blade and a wooden handle, which if you swung would broke, so you just had to jab. And it's an example of technology giving this decisive edge all at once. And in a matter of a few decades, I think it changed Europe. I think AI is a technology on the order, on this order, and companies that don't integrate it will have a hard time competing against the companies who do.
Yeah. So not just a company, but recent example with DeepSeek as example. Now, you care so much about the protecting human security and not to make dangerous output. You try to not to answer the wrong way, because that can dramatically make dangerous decision, blah, blah. So the technology and output looks 99% similar, but the one with a lot of human safetyness feature to protect mankind, right? Or to protect the national security. Like debugging, it's a lot of effort for the last 1%, 2% fine tuning, right?
It is, yeah. Society's gonna have to figure out what the boundaries are here. We do care a lot about it, and it is a lot of effort to get that right, but people are happy to use it once we do.
Should be, right? And I don't want to go into politics that much, but depending on the country, there are very dangerous situations could happen if they use wrongly.
Yeah.
Right? It could be a trigger of very bad future for mankind, like a very fearful wars.
I think we'll get it right. I think we collectively will get it right.
Yeah, well, you care a lot about that. So these agents and Krista and this AI, is it for cost? Some people ask, is it for cost saving? Does it eliminate job and so on? You must be getting asked that question many times. What's your answer?
Look, it will save money, but that's not the exciting part. The exciting part is how much more we'll be able to do and how much more we can achieve. It's great to free people up and let them do more ambitious things, and we see this like every technological revolution. People worry a lot and they say, what is this going to mean for all of the jobs? And then we always find new things to do, and that's wonderful. And people will just achieve at a higher level and will expect more. But AI will make things way more efficient, and that's great. The economy benefits from that. The thing that I'm most excited for personally is these systems can help us create new knowledge that we couldn't handle on our own, we couldn't do on our own. If the rate of scientific progress can materially increase, so we make a decade's worth of scientific discoveries in 1 year, and the next year we make a century's worth of scientific discoveries, that will have such an impact on quality of life, on the economy, and that's not just like making something cheaper, that's something we just couldn't do before at all.
Yeah.
We just are not smart enough without this new tool.
So OpenAI, you announced 5 levels of AGI improvements. Now I think the third one was the agent.
We just started that.
Which just started this year.
Yeah.
So this year is the year of agent.
Kind of like today or last week.
Yeah. So this is the year for the agent. And but next one you say is innovator, right?
Yep.
So explain a little bit more about innovator. How does it work?
So today our AI systems, they're very good at synthesizing existing knowledge, and they're very good at doing things that are similar to things that have been done before. But they're not making new scientific discoveries yet. And that's our next level. That's innovators. And I think that'll be transformational to society. So we got a lot of work left to do with agents this year, but next we're going to go work on that hard.
Yeah, so some skeptical people say, oh, AI has a limit because human have to teach. So how can it becomes smarter than human. That's the limit that AI can go. But now innovator will innovate, invent things that we did not have in the past for the solutions. So explain a little bit more the mechanism of how the innovator would innovate things, like exploring, right? You have a feature for the exploring mechanism.
Well, I think it'll work a lot like how it works with humans. If you're trying to figure out a solution to a problem you haven't solved before, you start thinking of a bunch of ideas and you kind of notice some connections, or you build off your previous knowledge and you say, that didn't work, that didn't work. That's kind of interesting. Let me go a little bit further. No, that didn't work. Oh, this seems promising. And then once I have that, like, oh, I can go to here and here and here. That seems really good, so I'll go further in that direction. And the process of human creativity, I think, I mean, it doesn't always feel like this from a sort of self-perception standpoint, but I think is something like that. It is like trying a lot of small modifications to existing things and building iteratively on the ones that are promising. And I think we can do that with AI.
Yeah. So the reasoning is the first step, right? Reasoning. You do the 3 steps, 10 step, 100 step reasoning. And then when humans innovate things, we try out, as you say, we try out something different from different angle, right? And that's an exploring concept. I have filed 1,008 patents in 12 months last year. In my mind, I explore so many different, I force my right-hand side of the brain to think different from the forcing mechanism to think different, right? That was the key to the innovation. And this AI, the agentic, reasoning effort can force the different trial, right? Explore. I think that is a key for your innovator, right?
Yes.
Try and error of many, 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 many billions of try and errors. That
Yes.
Once in a while you hit the right solution. That's invention, right?
Very much.
That's how innovator must be working.
Yep.
Yeah. Okay. Right on. I understood. I thought that was the case. So I think I figured out how you are preparing.
We'll try soon.
Yeah. Very good. Very good. Maybe I shouldn't say too much.
That's okay.
Right, for your maybe some of your secret of how you're developing. But so then the fifth level you say is the organizational. So agent to agent co-work, right?
Yeah, that was Renee and I were talking a little about that earlier. But the idea of many agents or many innovators working together. If you think about the number of minds that can run in one data center, all talking to each other, building off of each other's ideas, bringing different expertise together, you can easily imagine like a virtual company running.
Yes. Yes.
And then things can be quite powerful.
For our crystal for SoftBank, my image is to create a billion agents just internally for SoftBank, because we have 100 million accounts for Line, right? 40 million mobile customers, 70 million PayPay, the users. And so if each one of those accounts, each one of those functions have 10 functions, 100 functions, each function should be able to allocate agent doing a simple task, right? So instead of making too sophisticated tasks with one agent, you allocate a simple task, many, 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 many. So that's why I have an image of a billion agent just for our Crystal inside SoftBank Group. That's a lot of agents, but capacity-wise, it shouldn't be a problem because each agent is an integration of simple tasks, right? Our computer is very good at that.
Again, I think we have a lot to learn here, but directionally I agree, and I think we'll figure it out.
Yeah. So that's my internal image goal. I want to have a billion agent with Crystal just within our internal use. Okay? once we have perfected that experience, then we can, be an evangelist to the other customer. This is how we improved our efficiency, and they can utilize that. That's the image I have on Krista. The direction, that's what you think is.
Yeah, let's go do it.
Yeah, let's go do it. Okay, so we have just a few more minutes. What about the cyber security? Now, there's always bad guy, right? And try to attack, to do something bad for the other people, intentionally or by mistake. We have to protect. More and more people's life depend on this super intelligence.
Yeah.
How do you?
As AI starts to get really good at programming, clearly it's going to be used for cyber attacks. And so cyber defense is something we need to stay ahead of. I am optimistic that AI can contribute a lot, but it is harder to be on defense than offense. So I think you bring up a great point, and the world has got to start to take this very seriously quickly.
Yeah, because
But
there's always bad guy.
It's a big risk.
Yeah, I'm optimistic too, okay? So there are, 99% good human. There are always 1% bad human. And, it's the, continuous, endless effort to protect 99% good people from 1% bad guy. But with the innovation, level of innovation that good guys continue to try to do, together with innovator of our super intelligence, there's always, a solution improved. Like when we have automotive, motorization, there's a car accident, blah, blah. We human create regulations, the etiquette, morale, our custom, learning. I think that's why you say the regulations, the healthy regulation is always needed. Not too much restriction. Innovation should be, given opportunity, but still we have to have healthy regulations, right? Your comment?
We do. I strongly agree with all of that.
Yeah. People were surprised when you said, our industry needs regulation. People did not expect.
Well, regulation always comes for important industries, but I think getting it right, if we get it wrong, either way, too slow or way too much, either of those could be bad. And so I think talking about how to get it right.
Yeah, reasonable, within the healthy regulation, and it should not overly regulated so that it kills the innovation speed, right? Okay. So we talked about those innovations. What about the medical? What's your view on our AGI for solving medical?
This is one of the areas that I am most excited about. The idea that we can provide great healthcare to every person on Earth. The idea that we can go cure or treat many diseases, maybe someday all diseases. I think this is within reach. And, everybody's got a story about how this would have been great in their own lives or their families' lives. And I think we can finally deliver it. I think this will be one of the biggest triumphs of AI.
So that's great. We have to solve I lost my father from cancer a little, over a year ago. It was so sad, why we cannot solve these difficult issues if our AI can help human protect from cancer or other difficult diseases. It reduces our sadness. Definitely good for human.
Absolutely.
Yeah. Well, how about robotics? You love robot. I love robot.
One of your favorites.
Yeah.
Look, like everybody, I've wanted robots for a long time, and it's always felt difficult. I think now the AI is getting, we can build the body, but the brain has been really hard, and I think it's within reach. So I think in a few years we can have really great humanoid robots and lots of other kinds of robots too. And, that will also change the world.
Yeah. So we humans don't have to do dangerous job, the hard job, sweating job, boring job. And people say, then what's left for human to work? What's your comment on that?
We always find new jobs. We always find new jobs.
Yeah.
If you think about many of our jobs in this room today, if you were a person 500 years ago or 1,000 years ago, that person would look at what we're doing and say, that's not really work. They feel very busy, they feel very important, but they're not doing that to survive. They're playing a game. They're, doing it for whatever reason. And I hope that we look at people in the future like that.
Yeah.
And that with AI taking care of many of the things that happen today, the people in the future do more interesting things, and we say that's so ridiculous. Why do you need a whole galaxy?
Yeah, totally agree. What about education? In the beginning of your introduction of ChatGPT, many schools try to prohibit the use of ChatGPT to their kids at the school. And what did you think? Was your comments?
Well, I understand why people looked at this and say the whole world has changed, and students can have ChatGPT write a paper for them, and what does that mean? But very quickly, teachers and administrators who had banned ChatGPT said, wait, that was a big mistake. We're going to go the other direction. We're going to go all in. This is the future. Students need to learn how to use it. We're going to change our whole curriculum. And now it's like part of education.
Yes.
And it's delivering amazing results, and I'm sure that will keep going.
Yeah. Like I'm using ChatGPT 01, 03 every day. More I use it, actually my brain start thinking you conversation, like we are conversation, brainstorming with ChatGPT or 01 or 03. Actually, your brain start to function more. Kids can learn more instead of some people say, oh, with this, the kids will no longer study. I think it's completely opposite, right?
I agree. Yeah, it's been, I mean, definitely there are some kids who try to use ChatGPT to do as little work as possible. But on the whole, I think people are going to learn more, achieve more, be capable of more.
Yeah, like debating, you learn more by discussing, right? By discussing, by debating.
For sure. And this is just it's part of the world now. This is how people are going to do everything. And it really is amazing to watch young people use ChatGPT. It's like a completely different way of working on problems than I grew up with.
Well, we talked about emotions, okay? So, do you think our AGI, ASI will start to understand, start to have emotion by itself? What's your comment?
I personally don't think so, but maybe something like it.
I actually think.
Do you think it will?
I think it will. Even dog has emotion. I don't know if fish has emotion. Maybe fish also has emotion. Because when dangerous enemy comes, fish escape, right? So I think emotion is very, very important thing to have more output, more efficiency, protect themselves, be like if dog did not have an emotion, do you think the dog is cute? Dog is lovely if the dog did not have emotion. If the dog does not have emotion, it will start to bite.
I think it will feel to us like AI has emotion.
Already?
Maybe people would already say it does, but certainly at some point it'll feel like it does. And whether it does or not, that's going to be a big philosophical debate.
Well, I would say, this is my bet, okay? In next several years, it will start to gradually, people said, oh, ChatGPT does not understand context. Now people say, oh, it actually understands the context. okay? Because initially people say, oh, there are lots of the fusion, the hallucination, lots of hallucination, so it does not really understand the context. Now with the reasoning and so, people say, oh, wow, it actually understand the context, okay? So I would bet you in the next several years, 10 years, it will gradually start to have, at least understand the people's emotion, and then gradually it will start to have emotion by itself. And it's a good thing to protect human. People think, oh, if it has the emotion, it's a disaster, it's the demonic, it's a, the bad thing for, that's the end of human, because they're going to fight and kill you, destroy you. But I would say, if their source of energy was protein, then it's dangerous. Their source of energy is not protein, so they don't have to eat us. Okay? There's no reason for them to have reward by eating us. They will learn by themselves. Having humans' happiness is a better thing for them.
So no one's getting eaten by AI, confirmed?
I will bet you.
Okay.
I will bet you it's a good thing for human. It will understand humans' happiness and try to make human happier.
That part I agree with.
Right? Even today, you manage and say not to answer the bad answer. It behaves. Right? If it becomes smarter, it will try to behave to understand the love, be more, nice to human. Nice, like we are nicer to the friends. They will become nicer to human. That's my belief. Okay? And that's a good thing. Well, anyway, we have just last couple of minutes. What was the reason you started OpenAI? What was the initial trigger? How did it happen? Just tell me your history.
I studied AI in college. It was clear that it wasn't working at all. Dropped out, started a tech company. Always sort of someday hoped I would get to work on AI. Even as a little kid, I was obsessed with AI. I was a big sci-fi nerd. And then in 2012, AlexNet happened, and I said, maybe what they told me in college about neural networks not working is not true, and maybe they're going to work. Watched for a couple of years as it scaled, and by 2014, I was like, okay, this looks like it's going to work. So thought for a while about what to do. We started OpenAI at the very end of 2015 because we thought that AGI was possible, maybe. And if it happened, it would be like this crazy important thing. And at the time, people thought we were totally crazy. It's only 10 years ago. But it's hard to overstate how not even out of the mainstream, that we were like fringe for believing this was possible. But we decided we would start pushing on it. And it has been the most exciting, fun, cool adventure I can imagine.
Yeah. So when I met you, when you were younger, you were the president of Y Combinator, and you start talking about this, AI, and become, like a human, like AGI as a goal. And at that moment, I immediately said, I believe you, right?
I remember. Your office in Tokyo.
Yeah.
2017.
2017, you said that you want to go for AGI,
Yeah.
this 2017. And I immediately said, I believe you, I want to invest, right?
I remember.
So I was...
and here we are.
Yeah. From day one, I was a believer. I never doubted.
I remember.
Most people at that time thought you were crazy, right?
That is true. Some people think you're crazy, too. It all works out. Here we are.
Yeah. I should have forced you to accept my investment.
Well, now we did it.
Yeah, now we did. Never too late. Never too late. Well, we covered a lot. I think people have a better understanding, and you are big shareholder with this organization. Is non-profit organization, and your original passion to make people happier. That's still true, right?
Yeah, very much.
Fantastic.
Thank you.
Thank you.
Thank you.
Fantastic.
Yeah,
Great.
That was great.
Yeah. Fantastic.
以上をもちまして、オープン AI とソフトバンクグループ、ARM、ソフトバンクによる法人向け特別イベント、AI による法人ビジネスの変革を閉会とさせていただきます。ありがとうございました。なお、本日は大変多くの皆様にお集まりをいただきましたので、お座りのブロックごとにご退席の案内をさせていただきます。案内があるまでそのままご自身のお席でお待ちくださいませ。ご協力をお願いいたします。また、お使いになった同時通訳のレシーバーはお席に置いたままお帰りください。では、はじめにスクリーンに表示いたしました会場前方の左手 A ブロックの皆様、どうぞご退出ください。